So welcome back. In this video we are going to discuss about the anomers. Okay, so anomers are those isomers where there is difference in configuration of atoms at carbon number 1 in case of aldoses and carbon number 2 in case of ketoses. So let me write it over here. It is actually these are the stereoisomers where there is difference in configuration of atoms or molecules at carbon 1 in aldose sugars, for example, glucose is an example, and where there is aldehyde group as a functional group, and carbon 2 in ketoses. Okay, so anomers are actually the stereoisomers or the structural isomers where there is a difference in the arrangement of the atoms or molecules at carbon number 1 in case of aldoses. Aldoses means those sugars which are containing the aldehyde group. For example, glucose is an example of the aldose sugars, and ketones are those which contain keto group as a functional group over there, as fructose is an example of keto sugar, right? Okay, so this is glucose is an aldose over here. So if OH at the carbon number 1, if OH is on the downwards, OH is on the lower side, then it is alpha. We call it as the alpha. If OH at the carbon number 1 is on the top, we call it as the beta. Clear? Okay, let me draw the structure. It's alpha over here. Why it's alpha? Because OH is on the lower side. Okay, that's why alpha. If the OH is on the top, we call it as beta. For example, we'll make another structure of glucose over here. This is carbon 1, 2, 3. We have got 4, 5. We got over here CH2OH, and over here it is simply H. We have OH, H at 3. We have it's H and OH at 4. We have OH and H on top. Clear? So let's have a look at the carbon number 1. See the carbon number 1 here in case of alpha D glucopyranose. This is alpha because OH is on the lower side, okay, downwards, and here the OH is on the top. See, the OH is here and H is lower side. The OH is on the top. We call it as the beta D glucopyranose. So this is beta because OH is on the top. This is alpha because OH is on lower side. Clear? So these are the two anomers. So what's the difference over here? The difference is the arrangement of the atoms at carbon number 1. See the carbon number 1 over here. It is OH downwards, H upwards, OH on the top, and H at bottom. So this is the difference between the two. That's why we call it as the beta D glucopyranose, and this is called alpha D glucopyranose. Why alpha? Because it is alpha anomer, OH on the lower side. Why D? Because it's dextro, it rotates the light towards the right side. Why glucose? Because glucose is a molecule from which it is formed. Why pyranose? Because the hexagonal ring is called pyranose ring. Okay, similarly we have got beta. It's beta D, beta because OH on the top, D dextro glucopyranose. So these are two anomers. Okay, so anomers are the cyclic isomers. Anomers are the cyclic isomers where there is the difference in the arrangement of atoms at carbon number 1 in case of aldoses and carbon number 2 in case of ketoses. Okay, Hope you understood this clearly. This is a very crystal clear concept over here. Don't have to ponder over it, just don't have to contemplate for a quite long time. Very simple thing. Have a look over there, recap, rewind the video if you don't understand clearly, and definitely you will inshallah understand it. Thank you very much.